already, but we're publishers of International Cement Review. We've tried to tie in each webinar to the content of our magazines. So if you're interested in what you're hearing today, there'll be related content in the current issue of the magazine. Please do take a look online at cemtech.com for more information. There's a wealth of resources there across cement manufacturing technology and markets as well. But for those of you who are engineers and operating plants or owning assets and wanting to know what best practices and explore all the different phases of cement manufacturing, please do take a look at the Cement Plant Operations Handbook. It's free with the ICR subscription, and it's a great resource. It's been published, it's now in its 7th edition, published and used all around the world, a lot in training as well. So whether you're a junior engineer or an experienced engineer, I think there's a lot in there for you, and hopefully, if you haven't seen it already, you'll get a copy soon. So as I said, we're going to be talking about energy reduction in cement plants today. It's our penultimate webinar. Next month, we'll be looking at more themes around digitalization. But today, that's our topic. And I'll just ask you now to take a look around the Zoom interface, and you'll see options there to get involved in the chat, introduce yourselves and where you're from and which company you work for. But if during the presentations you have any questions for any of the speakers or anyone that you'd like us to address, please type it in there and I'll try and address it at the end of each presentation. So on to the agenda. 3 really impressive presentations. I'm really delighted that we can bring you such a kind of coherent set of content for this subject. We'll be hearing from Cal Portland in the US about their very successful energy management programs that we've kind of been watching for many years here at International Cement Review, but it's great to be able to have Bill Gerald here to present that to us later on in the webinar. We also have Jonas Schroeder from Claudius Peters, a company that many of you will know already, who'll be talking about pneumatic conveying systems. But first, we have dialing in from India. We have Mr. Kotagiri from RITES India, who will be taking us through energy efficient and reliable process fans. And while I make his introduction, if I could just ask him to share his slides. Mr. Kotagiri, if you could get that slide deck up. Based in Hyderabad in India, Mr. Kotagiri is a qualified mechanical engineer with extensive experience working across different industrial sectors. And he spent 13 years with FLS India, holding various positions in marketing and project management of cement plant machinery. So a great background in our sector. For 23 years, he's held the position of managing director at RITES India, which is an Indo-German joint venture company involved in the marketing, design, manufacturing and servicing of centrifugal fans. RITES has been at the forefront of fan technology for many years and has a strong focus on designing and manufacturing energy efficient fans for the cement industry. And I think we'll hear later when fans consume up to 25% of power in a cement plant. So they really are an important consideration when seeking to reduce electrical energy consumption. So we're going to hear from Mr. Kotagiri now and look forward to your presentation. So welcome to cemtech.
Thank you very much, Mr. Armstrong. It's a very nice, introduction of us to all the dignitaries and people who are present watching this. So we, in this presentation webinar, we are trying to address, how to improve the efficiency of the fans and make it, reliable fans, as well as also reduction in the power consumption of the cement plant fans. And what we are doing as a company and as a group to address this issue worldwide. Just a very brief introduction of our group. Rights Group, is a big group all over the world. We have operations. We have about 10 companies all over the world, including India, 3 companies in Germany, 1 in Brazil, and also we have operations in Middle East, Southeast Asia, and we have a company which is Rights Phelps fans also in North America. As far as India is concerned, India is the hub for the cement fans for the global market. That is, we design, engineer, produce the fans for cement industry. We have expertise almost for nearly 23 years. As Thomas has already mentioned, we are Indo-German joint venture company, started operations in 1998 in Hyderabad, which is the central part of India, and we have offices all over India. This is not just a technical collaboration, there is also equity participation by our partners from Germany, and a very strong relationship going on for 23 years, which is, as you know, that it's 23 years is a very long period to continue the partnership. We have produced and delivered over 35,000 fans all over the world. It's not only, again, not in India, but all over the world. We have 2 or 3, actually 3 production facilities in Hyderabad. One is the Pasha Mailar facility where we have our offices also here. About 350 people are working, 12,000 square meters of area, and all the state-of-the-art machines we have for manufacturing of the centrifugal fans. And the second facility we have, which is also very close by, about 10-15 kilometers from here, where we have about 150 people are working and about 5,000 square meters. Again, here also we have some huge machines that help us produce quality product for the global markets. Apart from this, we also have a third facility, which is at a place called Vijayawada, about 300 kilometers from here. Unfortunately, I'm not able to share, many photos of that. Maybe future, I'll try to, share that information. It just started, and it is. We have about 100 people working there in that facility. What is our range of, our range of parameters? That is, what is the minimum that we can offer and maximum that we can offer for the cement industry. On the pressure front, the minimum we can give about 100 millimeter water gauge. We can go as high as 5,600 millimeters for 2-stage, 3,000 plus for single stage fans. Flow as low as 350 meter cube per hour. We can go up to 2.8 million meter cube per hour. It's a big increase. Temperatures, we can go -40, -50, particularly in cold countries, maybe countries like Russia and Ukraine and all these countries, they see these temperatures. Plus 500 degrees centigrade, that's operating temperature, particularly for preheater fans and other, kiln ID fans can go up to 500 degrees centigrade. On the smaller side, we can build as low as 2 kilowatt fan and can go up to 12,000 kilowatts. Efficiency, I'm talking about static efficiency of around 89% approximately. Typical view of a cement plant, and the one in the red color are the, you can see these are the several fans. Ideally in a cement plant, 200-250 fans are there for different applications, and so there is out of which about 7, 8 or maybe 10 fans are the process fans, which are the heart of the cement plant. And if these fans don't operate, the plant has to be shut down. Typically, we believe approximately around 1/3 of the cement plant power consumption is consumed by these fans. So any reduction in the power consumption of these fans by increasing the efficiency of the fans is going to give a substantial saving in terms of the cost per ton production of the cement, and the owners are happy. I mean, if they can reduce the power consumption and increase the productivity and increase their revenues and profits. So this is always very welcome, in the cement industry. The process fans, which consume, nearly 20% to 25% of the power, is the raw mill bag hose fan, mill fans, the preheater ID fans, coal mill fan, exhaust fans, separator fans. So these are the main, fans that where we have to take utmost care in the design and the production, so that the highest efficiency of the fans can be obtained from these. So what do we really, what is the selection criteria that we really use for the cement plant fans? One is, the important thing is the material selection, which is very important, because these handle different kinds of, different kinds of dusty atmosphere sometimes, and the flows and pressure. So the strength of the impeller is very, very important. And the design of the shafts, the selection of the shaft, the material selection of the bearings and couplings. And another important factor is the wear protection, because you see different kinds of wear. For example, the clinker dust is different from one place to another place. Say for fans operating in India, they find a lot of silica content, which means that there will be a lot of wear and tear of these the fans. You go to Africa, then there could be some some alumina, some little bit of other other materials are there. Again, that will damage the impeller very fast unless we take proper wear protection. And once we do this, then we have to derive at the motor ratings based on the starting conditions. Then the manufacturing will start the static and dynamic components. Sometimes these are also gas tight construction we have to do. We are looking at improving the efficiency, which is the main criteria, by doing upgradation also of the fans. The existing fans are running for a long period of time, older design, the technology is old. So without changing, many components, increase the efficiency of the fan. And this is another, very cost-effective solution and a kind of win-win situation for most of the customers worldwide. The engineering front, we have a complete, setup for selection of the materials. We have the ANSYS program for selecting the finite element analysis of the impeller. Before we take it for production, we check how safe it is to the impeller that we design, and then we go for the next stage of production. The construction, we can give all kinds of construction. We have the CE marking fans, particularly for European market, ATEX, dual-driven fans, gas-tight, APIs, American pollution, American petroleum, industry, API 673. The design validation is FEA, finite element analysis, and shafts, we take care of the torsion analysis. The features for designing the high efficiency fans, basically we have brought down, minimum 4 or 5 basic things. The profile of the blades is very important. Higher blade angle is not very good. And at the same time, we should not keep the blade angle very low, then the efficiency fall down. So optimum blade angle, 40, 45 degrees, is most ideal situation, as you can see in this picture. And then the involute of the casing. The casing, the design of the casing is also a very important consideration for the efficiency of the fans. We have to design in such a way that there is a smooth flow of air at the exit. Also, there has to be a smooth flow at the entry. This is very important. The third consideration is about the inlet cone. We can't, keep the inlet cone very too much distance to the impeller. We have to keep it closer. At the same time, there should not be any gap, not much gap between the shroud and the inlet cone. And the design of the inlet cone also should be smooth. There should be have a smoother airflow into the impeller. And again, the construction of the inlet box. The inlet box should allow the flow of the air entry into the impeller in a very smooth manner, and for which we sometimes also provide anti-swirl plates for increased efficiency of the fans. Then the ducts also play a very important role, that there should not be any deposition of the ducts. So there should be a smooth entry and exit from the ducts. No obstacles inside the duct, and to maintain a proper vent angle. It should not be too low. At the same time, it should not be too up flat, at least 40 degrees and above. It should maintain. And the design of the diffuser at the exit of the fan is also has a very important consideration for the efficiency of the fans. And there is again the layout constraints sometimes we have to address, and there should be, if you use a damper at the inlet of the fan, then there will be a lot of vortex formation, and again you have to use some anti-swirl plates to cut down this vortex to reduce the losses in order to increase the efficiency of the fans. All these considerations play a very important role in the design of the proper fan and increasing the efficiency at various stages of the application. Then we get into the retrofit. We believe that most of the customers nowadays worldwide are looking at minimizing the expenditure, keep the existing casing as it is, keep the bearings as it is, and most times even the coupling also, the motor, everything will be retained as it is. Only change the internals, which means change the impeller, change the inlet cones and the shaft. So by doing this, we can really reduce the downtime is reduced enormously, and whatever is the new conditions customer is looking at, we can achieve it with a greater efficiency of the fan. So we believe that this is the really a great situation now happening all over the world, where customers are looking at only retrofitting, not for change of complete fan. It's most times it is not necessary to change the complete fan at all. If you just only replace the old impeller with a new one, some key important things we have to take care. Again, the design of the impeller has to be a proven design, and keep the existing impeller diameter close to the existing impeller, so that we can insert it very easily into the fan, and then maintain the exit gap is very important. That's normally between 6 to 13%. We try to keep this gap opening. If it is too low, then there is a recirculation of air taking place, and if it is too high, then again also there is a problem. So we maintain between 6 to 13%, and we try to retain the existing coupling and motor also, provided the required parameters permit to use them. So we just trying to run through some of the examples. This is a plant in Lafarge, that's in Bangladesh, where the old fan has these conditions. Again, the dotted lines are the old one. We just only replace the impeller shaft assembly. We can see this maintain the same flow. Slight increase in the pressure. The customer desired more pressure, but the same flow he wanted. About 150 kilowatt of power saving. Right from the day one of operation, the customer is getting this, his money back. Sometimes in 6 months' time, you can get back the investment or whatever we invest on account of saving in power consumption. This is again a plant in Dangote in Senegal, where the savings more or less same flow and little reduction in the pressure they wanted, and but more than 1594 to 1316 is 280 kilowatts of saving in power. It's a very big saving, day in and day out, they get this saving in power. FL Smith, my ex-company, ex-customer. I mean, he's a regular customer, my ex-company. So here again, the same flow, same conditions before and after, but nearly 180, 190 kilowatts of saving in power consumption. This is the application in the raw mill baghouse fan. Of course, this is supplied to Denmark, but we don't know where this plant is. I don't have the information, but this is again a big saving as far as the customer is concerned. This is a YTL plant in Pang, Malaysia. Here the savings are little less. 431 is the static pressure to 450, 5% increase in the pressure, but maintaining the same flow. We designed the impeller. 510 to 470, so 40 kilowatts of saving in power, almost at the same speed of the fan operating. This is for a preheater fan application. Again, only impeller, shaft, assembly, existing casing, existing coupling, everything is retained as it is. So the advantages of having this is very increased reliability. We save right from the day one. We start saving the money on account of saving in power consumption, better performance of the fan, improved energy efficiency, return on investments. As I just mentioned, it's sometimes as low as 6 months, in 1 year, 2 years time. I mean, most of the applications, they get back this money in a maximum period of 2 years. Replace the old and obsolete internals, increase productivity of the plant, and of course, by reduction of the power consumption, help the environment. We can also undertake some testing of the fans. We have up to 400 kilowatt complete test facilities there, where we can do before the supply of the equipment, we can do the testing, how the performance of the fan and all that. Of course, all these fans are tested fans, tested models, running for 50 years, 60 years like that. So really, we don't have to do this, but sometimes, we do offer this opportunity to the customers. So some of the OEMs that we are working with, Schmidt, ThyssenKrupp, German companies, and Humboldt Vidal, Sinoma, Chinese company, Bosch, Germany. So again, this list is partial. We do have a lot of other OEMs we are working with. Customers all over the world. We have Italy Cement, Nuvoco, ACC, SCG is a big company, largest cement producers in Thailand, Heidelberg in Germany, Votorantim. Holcim is a very, very big group all over the world, CRH. So with this, thank you very much for giving this opportunity. And I'm ready to take any questions on this, either through chat or through any other means. We can also come back to you on mails. Any questions you have on our presentation. So thank you very much.
Thank you very much, Mr. Kotagiri. Very interesting overview of your services and your manufacturing, and you've clearly got a lot of impressive references as well, really showing incredible energy reduction potential. I wonder what the conditions were for some of these fans that were retrofitted. Were they fans that had that were old? Had they been used in a particularly aggressive environments? What's the kind of main area of the plant that you see requiring these retrofits?
Yes, so some of the old fans we have for 15 years, 17 years, they have been operating these fans, and the life of the fans is quite good because we are studying the existing conditions, checking what kind of sometimes what kind of dust concentration is there, what is the parameters of the dust. We do take the samples of the dust, we check for what are the materials are there. Accordingly, we are designing the lining, wear protection for these fans. So considerable life is there for these fans, and we have a very, very good feedback. And most of these customers are coming back to us for repeat business. We are giving more and more to the same customers. changing the internals and offering this retrofit program. But it's again, we have to be very careful with this. We have to check the existing conditions, and sometimes our people go there all over the world. We do test the conditions and then come back and then make a proposal to the customer. So it is not a very straightforward thing, but it is very, very useful and very cost saving to the customers.
So each fan has to be customized quite specifically for each plant and each application within the plant for the retrofit. I mean, you use CFD modeling and this kind of thing. Is that the process? What's the process for a retrofit? And can you talk a bit about how long it takes to get a new fan made?
Yeah, actually, this we do make a survey of the fan. We have some standard formats which we first give it to the customers. Then the customer will provide us some data of the existing conditions. Typically, if they have some drawings of the existing old fan, old casing, we can provide to us. So based on that, we just see whether we can insert our new design impeller into the casing. Because most cases that is not a problem, because these the old fans are very big, but nowadays the new designs are very different. So that problem is not there for inserting this. Then we make a study. Once we are absolutely confident, then we give the guarantees to the customer. That is, this fan will deliver this efficiency, this power consumption, and you will have a saving of this like that. And once we do that, normally it's between about 12 weeks. We normally need to make this big process fans, impeller and shaft assembly. Sometimes if this is very big, then we can go up to 16 weeks, and then we deliver to the customer. Normally, whenever we plan this to the shutdown of the plant, whenever there is a yearly, they have one time or 2 times shutdown is there, varying between 15 days to 25 days like that. So this we will deliver such a way that it needs a shutdown. Then our people go there and we install this new design impeller, and then we run it and show the performance to the customer. So
yeah, we have quite a specific question here. I'm not sure from which country, but the question is: we are using AFR fuels, alternative fuels, in the preheater. We are observing that impeller wearing is high. Please suggest which one is best for AFR fuel firing. So are there certain designs or materials or wear protection that you would specify in terms of alternative fuels environments?
Yeah, we have to go for a high hardness materials, like we have this tungsten carbide material now available in the market, and so we that gives at least 3 to 4 times better life than the chromium carbide. The chromium carbide is a little bit lesser life, but less expensive. But you go for tungsten carbide, that is the best. I propose that for alternative fuels of different, different combinations which the customers are trying out now, we must go for the safest, wear protection material, and the best available in the market right now, which is the tungsten carbide materials.
Okay, so you have a lot of various options for more durable protection, wear protection. A question from Wholesome Corporate Office, Switzerland. My question is, for protection of the fan impeller and to prevent accidents, what are the safety features you recommend for process fans?
Of course, what number one is that the design of the impeller and the shaft has to be properly designed with high strength materials, and we have to do this. In all these cases, we very strongly recommend we have to do the finite element analysis of the design of these impellers, and then the torsional analysis of the shafts. So, in addition to this, if we could, sometimes there are cases, of offering some kind of braking systems are there, but not very popular in the cement plants. But other cases, in case, I mean, when you're operating this, when it is, suddenly stopped or something like that, then there is a tendency for the reverse movement of the, of the impeller. So there is some kind of braking systems are available. We do offer also to the customers. Normally, the cement industry, these are not very, very, very famous. So we still believe that, proper design of the equipment, these accidents, can be fully avoided. But yes, he's absolutely right that the gentleman from Bolsing, there could be, in case if the maintenance is not good, sometimes, people don't check the internals. They just, keep running and running. And if there is any crack or anything, it starts, then it will propagate those things. So the periodical inspections, whenever there is a stoppage, it's better to inspect these process fans, particularly fans that are handling dust environment. So immediately, if anything is found out, then the repair can take place and things like that. So otherwise, as such, what is the practice that's being followed is perfect practice in the cement plants, I think.
Okay. Well, thank you very much for that presentation, for taking those questions. Actually, there are quite a few more questions in the Q&A, and I'm sorry I don't have time to go through them all, but there's lots worth looking at there, and hopefully you'll have a minute to type in a few answers to those. But in the meantime, we're very grateful for your presentation. Thank you very much to Right India.
Thank you very much. Thank you, Thomas. Thank you all the other guests, and thank you for giving us an opportunity to showcase and give our expertise of long expertise in this fans for cement industry.
Thank you very much. Okay, and so on to the next presentation. I'm really delighted to be able to introduce our next speaker, Jonas Schroeder, who's Territory Sales Manager at Claudius Peters. If you'd like to share your presentation deck now, Jonas. So he's based at the Buxtehude headquarters, where he consults for national and international customers on their technical concepts. Jonas graduated from the University of Applied Science in Berlin as a Master of Engineering. Claudius Peters designs and manufactures and commissions materials handling and processing systems for the cement, gypsum, coal and bulk handling industries. From conception and installation through to commissioning and after-sales support, the company provides services to the world's biggest cement producers. So today, Jonas is going to discuss pneumatic conveying systems and ways to reduce energy consumption. So welcome, Jonas, and we can see your slides. Over to you.
Perfect, Thomas, perfect. Thomas, yeah, many thanks for your kind introduction and for sure for the organization of this conference together with your team. So well done, and for sure I appreciate that Claudius Peters and I can be part of it. And well, good morning, good day and good evening again to all of you who are joining this International Cement Conference, cemtech. I believe this is a great chance and opportunity to get in contact discussing about a topic that affects, influences and concerns us all even for the next decades. And this is energy reduction. In this particular case, we are talking about energy reduction in a cement plant. And today's Claudius Peters presentation will be about reducing the energy consumption of pneumatic conveying systems with our FluidCon. Many of you will probably have already done a lot to reduce energy in the cement plant, but FluidCon can be another step towards optimizing your plants. So let's have a look how this can be done. Yeah, as introduced, my name is Jonas. I'm part of the Claudius Peters sales team headquartered in Germany. I'm working as a territory sales manager and being especially responsible for the Asian Pacific region. And I'm with Claudius Peters now since more than 7 years. And the FluidCon system is for sure one of our outstanding products. And FluidCon gave lots of advantages to our worldwide customers up to now. And for the next couple of minutes, we go on a journey through these advantages and at the end, a different way of pneumatic conveying. But first we start with some basic figures around Claudius Peters itself. So since its founding in 1907, Claudius Peters has become one of the world's most respected engineering houses. We design, manufacture and commission materials handling and processing systems for the gypsum, cement, coal, alumina and bulk handling industries. So from conception and installation through to commissioning and after-sales support, Claudius Peters provides all kinds of services to the world's biggest bulk materials producers. And for the cement industry, we are not seen as a full liner completely, but are expert on different plant areas. And actually the cement industry is where Claudius Peters started and where it is still a world leader today. In all areas of cement manufacturing, Claudius Peters offers innovative solutions combining high production capacity with lower operating costs. And today our stockyard, silo, pneumatic conveying, clinker cooling, grinding, packing and dispatch technology can be found in hundreds of installations around the world. And for sure, most likely hundreds of installations will follow in the very near future. As mentioned, Claudius Peters is headquartered in Buxtehude near Hamburg, Germany. And we got some regional offices in the Americas, in Asia and in Europe. We are part of the Langley Holdings, and which is a diverse globally operating engineering group headquartered in the UK. Yeah, but at the end, let's talk about the actual topic of today. And this is pneumatic conveying and the way this conveying system can be optimized. Generally, Claudius Peters delivers positive pressure conveying systems. And in this diagram, or this diagram shows the structure of a positive pressure conveying system, where bulk solids are fed into the conveyor pipe against the conveying back pressure. Claudius Peters offers a complete range of feeders types, such as pumps, pressure vessels, rotary feeders, and double pendulum valves. The chart also shows the range and the features of available feeders along with their standardized range of applications. The compressed air will be supplied either from blowers, compressors, or of the plant network. And at the end of the conveying, the material will be separated from the air with cyclones or filters. But additionally, FluidCon provides a dense phase system with increased bulk material load. So therefore, it can be used to convey all fine bulk material solids that can be fluidized with low air velocities. And at the end, depending on the transport pipe routing, it can tremendously reduce power consumption. Yeah, FluidCon is a conveyor pipe that can partially or completely fluidize material over the horizontal length of the pipe, like the aeroslide principle. And indeed, FluidCon is a combination of a standard pipe with an aeroslide. Within the conveying pipe, you will find aeration pads all along the horizontal conveying route. And parts of the air of the compressed air supplier are used to fluidize the material. And parts of the air of the compressed air supplier are used to transport the material on top of the fabric all along the conveying route. The pressure loss of the transport airflow substitutes then for the inclination of the aeroslide. And the aeroslide principle turns the bulk solid into a fluid state with minimal internal friction. This way it ensures that it remains fluidized away from the bottom of the pipe and in the gas flow. And these optimum conveying conditions allow the transportation of solids with the lowest drive-in gas velocity. Yeah, it is therefore possible to convey material with the FluidCon system using minimal differential pressure at the end and through uphill inclines up to 30 degrees. Means as the first summary, our FluidCon system combines all advantages of aeroslide and conventional pneumatic conveying by avoiding any of the disadvantages. For instance, we achieve low wear and abrasion as well as flexible pipe routings, whereas we avoid high power consumption and high conveying velocities. When it comes to a comparison between different conveying systems and the energy consumption, it does make sense to set a reference value. And this diagram refers to a belt conveying system, which has normally the lowest energy consumption within different conveying systems for bulk solids. But however, the investment costs for such systems are quite high. And looking at the conventional pneumatic and the fluid conveying system, we easily see that there are big differences in energy consumptions. And at approximately 400 meter conveying distance, the energy consumption can be more than 5 times lower with fluid con. But how to get to know the material behavior and the knowledge whether fluid con can be used or not? With over 14,000 material samples tested here in our laboratory and test facility in Buxtehude, we have a good overview about materials that we conveyed in the past, but do also have an impression about new materials to come. In our laboratory, we are not only doing the standard program, but also constantly extending our testing capabilities, characterizing powders for our clients and for our own engineering projects. That is why for some industries, the Claudius Peters standard test protocol is the starting point to classify and characterize dry powders. And that is also why we are aware of nearly every powder that is handled in a cement plant, like cement itself, as well as raw meal or additives like fly ash, burnt oil shale, or calcined clay. See here one calculated example that we realized in the past. This is a typical intermediate cement transport in a cement plant. We convey 100 tons per hour of cement over approximately 200 meters with a vertical height of 25 meters. We used our Claudius Peters pump as a feeding device, and the flow sheet on the left-hand side may give the impression that we do face a complicated conveying system with lots of valves and flaps to be controlled and regulated. In reality, these flaps are adjusted once within the commissioning and never touched again. Basically, these flaps distribute the air from the compressed air supplier to the different section of the fluid con pipe. This means that next to the conveying pipe, there will also be a small aeration pipe. This one is directly connected to the fluid con pipe and do not need any additional support at all. And yeah, looking at the right-hand side and the comparison between conventional and fluid con conveying, we see that we save 35% power at the coupling of the pump, 52% less air, and 52% less operation costs in total. The good news is that we do not only supply the pump as feeding device for pneumatic conveyings, but can also choose the rotary feeder. And the even better news is that we do have a cooperation with the well-known rotary feeder supplier, Coperion. So for the past couple of years, we invented the combination of fluid con with a blow-through rotary valve. And one can say that this combination is not possible as the low conveying velocities of fluid con cannot match with the high velocities within that kind of rotary valve. But it is. The rotary feeder was adapted that way, lower velocities were achieved, and we created the most energy efficient pneumatic conveying system for high throughputs. So as an example, these 100 tons of cement or even more. The starting point for this adventure with Coperion, including tests and improvements, was our CP Technical Center. It's the playground where all our new inventions start. As mentioned, we got our own laboratory as well as test plants in industrial design and dimensions. And we can test every of our feeding device and conveying equipment beforehand and do some scale-up calculations for the equipment we choose. So we have our rotary valves, pumps and pressure vessels installed and ready for testing. And with conveying lengths from a few meters up to 5 kilometers, with either conventional or fluid con pipes, we are able to study all of the options, exploring new ground and providing innovative solutions when required. At the end, the target is always to find the best solution for customers' operations. And yeah, moreover, the test center is not only available to create basic design parameters for our projects, we also undertake contracted researches for existing plants. For example, for one customer, we investigated different conveying velocities with regard to the attrition of materials. But coming back to our first calculation example, we see that rotary feeders can add some more advantages to a fluid con installation. Compared with the fluid con with X pump, the fluid con with rotary feeder saves another 26 kilowatts. However, it is not only about saving energy with the size of drivers, but also about having a look at the overall application of the pneumatic conveying system. What about capital costs or maintenance? Actually, there is not the perfect feeder for pneumatic conveying system that covers all for every single conveying task and project constellation. And that is why pumps do justify their applications in the same way rotary feeders do. At the end, the specific project constellation will lead to the correct feeding device. Either it is the pump or it is the rotary feeder. So let's have a look at the comparison between both feeders in general. So we compare four main categories that will always have a great impact on the decision whether to go with the one or with the other feeding device. These are capital costs, operation costs, maintainability, and total power consumption. As you can see, both feeding devices win two of these categories. Whereas the rotary feeder wins at operating costs and total power consumption, the pump wins at capital costs and maintainability. The pump can always be maintained in the cement plant easily, and the capital costs are rather low, as we do not need any ceramic wear parts. In comparison to that, the rotary feeder has a smaller motor size for operation, and therefore the total power consumption is considerably lower. But no matter how your specific pneumatic conveying will look like, I am sure that we can assist finding the right overall solution for it. And realized solution can look like this. We will now come to some installations around the world that underlines how flexible fluidicon can be used for pneumatic conveyings. Our example number one is not linked to the cement industry itself, but shows what is possible. On the picture, you can see an alumina conveying in Russia, and this has two special features. On the one hand, alumina is quite hard to convey, as its duration time is approximately 5 seconds compared to 50 seconds of cement. And on the other hand, we convey through an inclined pipe arrangement. This was construction-wise the best possible solution, as we had to span the existing smelter building. Conveying throughputs were about 135 tons per hour over 440 meters conveying lengths. As there wasn't any space under the existing silos, we used pumps as feeding devices. And fluid con installations for alumina saves approximately 35% compared to 75% compared to conventional pneumatic conveyings, and for cement it is approximately 50%. The next example takes us to Australia. At the harbour side, a big storage silo is fed by ship with cement. From here, the bulk material is conveyed to 4 smaller silos, which can then load trucks for the further domestic cement distribution. Originally, the big storage silo was equipped with a pump and a conventional pneumatic conveying system that feeds the loading silos. However, this conveying has reached its limits, and in addition to that, a new fluid con system was installed. You can see the conveying line here coming from the silo shell all along to the loading silos. And at the silo top, we divert the material to 2 silos with the option for a third one. The biggest challenge under the storage silo was the space limitation. See the photo on the left-hand side with feeding device and on the right-hand side with fluid con piping. As the silo discharge is located in a basement building, fluid con and the feeding device were adapted to this situation. Moreover, we had to think carefully about the dusting situation as filters couldn't be installed right over the feeding device. In the end, we went for a rotary feeder that was directly fed by the silo discharge. And in this way, we could convey 120 tons per hour of cement over a conveying length of approximately 115 meters. The dedusting air was collected at the rotary feeder inlet, brought to a separate filter outside the basement, and fed again to the conveying pipe with an additional rotary feeder. This additional feeding point was located several meters after the original start of the conveying pipe. Next to cement conveyings, fluid con is also applicable for additive transports. One of these were realized in Switzerland. The material was the so-called burnt oil shell, which can be added during the mill process to cement. This oil shale is transported with rail wagons to the cement plant and needs to be unloaded and conveyed to a storage silo. On the picture you can see the start of the fluid con pipe as a rail wagon unloading station. With this installation, 4 wagons at the same time can be connected, feeding the same pipe. And in total, we achieve approximately 180 tons per hour conveying capacity towards the storage silo. The further conveying route proceeds then underground, as you can see here. Nevertheless, the wagons can still be connected above ground. These connection points you can see here. And also at the end of the conveying, the fluid con pipe goes straight into a silo here. Yeah, last but not least, we travel back to our home country, Germany, where we can find an installation for fly ash conveying. And similar to the installation before, a storage silo is fed with rail wagons. And under this silo, the following arrangement can be found. Looks like this. A Claudius Peters X pump is fed out of a dosing bin. And this pump then feeds the pneumatic conveying with fluid con to the cement mills with approximately 30 to 50 tons per hour. And the main task of this conveying is the even transportation of the dose throughput without any further fluctuations. Yeah, at the end of this fluid con journey, we come to a summary which shows again what can be possible with a different way of pneumatic conveying. So we achieve energy savings up to 75% and low conveying velocities with low conveying pressures. Moreover, simple restarts of the conveying after emergency stops are possible, and the operation is pulsation poor. This fluid con system can optimize existing plants using blowers instead of compressors. However, the main argument remains operational cost savings. And if you want to know more or receive your own comparison with FluidCon, feel free to contact us at any time. We are really looking forward to our fruitful FluidCon discussions. And well, that's from my side so far, and actually the end of the presentation. And now it's up to you, Thomas, again.
Thank you. Thank you very much, Jonas. It was a really good presentation and a very compelling one for the FluidCon products. What is the most common application? Is it the transportation of cement? I mean, in the cement industry, is it really popular for kind of unloading ships and you know, supplying bagging facilities, that kind of thing?
Yeah, that's it. So as we could see, the main energy savings up to 50% could be achieved with the cement. So the bulk material needs a certain characterization or material behavior to save some energy. And cement is really one of the materials that can save a lot of energy. And we could even replace existing pneumatic conveying systems, so traditional or conventional conveying, by using the FluidCon instead.
And essentially it has the kind of fluidized bed with canvas, is that correct? And that allows the product to be fluidized with the air being pushed up, but from below. Is that can that cause blockages? Is there, does the size, the diameter of the pipe need to be larger to be able to accommodate that fluidized floor?
It's the other way around. So we avoid any blockages with the fluidized bed, because the internal friction and the friction and the material behavior is more positive for the pneumatic conveying, and that is why you do not need to put more transport air to the pipe. So compared to traditional or conventional pneumatic conveyings, where we convey with 20 or 25 meters at the end of the conveying, we can only use 12 or 14 meters per second, so considerably lower. So it's the other way around.
Yeah, so it's blockage free. In terms of the materials that you transport, there's one question about whether it's ATEX compatible. I guess someone's thinking about the transportation of coal fines, that kind of thing. Is that possible?
It's possible, yeah, sure. It's possible.
Okay. In terms of the limits of the density of handling the material efficiently, can you give any parameters there?
Yeah, so we even convey pretty fine materials, so like fine fly ashes, but it really depends on the fineness and on the weight of the material. So there is a limit or a limitation when we have pretty fine material, and this material in addition is also pretty light, so that when there's any material that is pretty sticky, like some kinds of kiln dust, there might not be any advantages by using FluidCon then anymore.
Right. So you'll always start from analyzing the material and then working out from there whether it's applicable, and I guess you can be quite sure of the likely savings from any particular installation.
Yeah, and for sure, if we do have any issues or queries with the material itself, we can analyze it in the laboratory, and we can test it whether it's applicable for FluidCon or not, or whether there are any benefits out of FluidCon. So this is also possible either during the project phase or with, for instance, contracts coming into force. So that's always an opportunity.
Okay. A question from Nigeria. What is the maximum tonnage that the FluidCon has been proven to transport? What is the pipe size at this maximum tonnage? Sorry. That's a very specific question.
Yeah, but I believe 200, I'm not 100% sure, but it should be 200 or 250 tons per hour. And pipe diameter should then be somehow like DN 400 or DN 450. So that should be the maximum. But I can answer this maybe also after the live session in the Q&As.
Sure. Another question about is it applicable for slightly abrasive materials like GGBFS and fly ash? But you said yes, so I think that's all clear.
Yeah, it is actually applicable because, or even more beneficial because, the velocities are even lower. So if we are talking about bends or all that stuff that is directly affected by wear, so it has a lot of advantages in this regard.
Okay, particularly then for those kind of abrasive materials. Can the FluidCon be used under the raw mill clinker main bag filter instead of an air slide or screw conveyor? Does that?
Yeah, should be.
Should be. Yeah. Okay, that's Berber Cement in Sudan. Okay, that's about it. There might be one or two more for you. A question about embedding sensors and IoT to offer any kind of data analysis. Is that anything that you've looked at incorporating into these systems?
Say it again. I didn't get everything.
Incorporating of any embedding any sensors. So we're talking digitalization, any kind of monitoring system.
No. So the fluid con system, as I explained, on the flow sheet may look complicated, but it is not. So these are really manual flaps or flow controller that are adjusted once, but it's not like a high sophisticated pneumatic conveying. So that's not the case.
Very good. Well, Jonas, thank you very much for that presentation. Really interesting and clearly lots of questions and interest from delegates today. Thank you very much.
Yeah, thank you too. Appreciate that we could be part of it, and looking forward to the discussion then with the Q&As.
Great. Thank you,
Thank you very much.
Very good. So there we are. That's our second presentation. And now we're going to move over to the USA, to Cal Portland. And I'm really delighted to be able to introduce Bill Gerald, who's just putting up his slides now. That looks great, Bill. He's the Chief Energy Engineer at Cal Portland in the USA. Very interesting CV. After working on nuclear submarines in the US Navy, Bill gained a BS in nuclear engineering from the University of Arizona. He started working for Cal Portland in '93 at the Cal Portland Relito cement plant, eventually becoming the senior electrical supervisor responsible for electrical equipment maintenance and repair at the facility. Bill became the corporate energy manager in 2007 and was eventually promoted to chief energy engineer. In this role, he's worked closely with Energy Star in developing the Cal Portland Energy Management Program. He's presented educational topics at Energy Star industrial events and the Association of Energy Engineers conferences. And today, he will present Energy Star energy management practices to reduce energy consumption at Cal Portland's Relito cement plant. So Bill, welcome, and over to you. The slides are all up. They look great.
All right, hey, I really appreciate the invite to present at this. We're always very proud of our energy management program here at Cal Portland, and like I said, I'm very thankful for the opportunity. As Thomas said, I'm William Gerald, or Bill Gerald, Chief Energy Engineer for Cal Portland. So Cal Portland is a cement and concrete company. We are located on the western coast of the United States, pretty much all the way up from Washington, Oregon, California, Nevada, and Arizona. That's our normal operating territories. We've been around since 1891. Original plant was in Colton, California. And I'm calling in from Riverside, California, just literally a few miles down the road from where that plant used to exist. It's no longer operational. It was decommissioned a few years ago. We have about 3,000 employees. We have over 100 facilities up along the West Coast, as I described. 3 cement plants currently, 2 cement plants here in California, and the 3rd cement plant is in Relito, Arizona, and that's the one we'll be talking about today. Some of the other plants that we have are in other active programs within Energy Star. We have over 60 plants in the Energy Star Challenge for Industry. The audience here kind of knows the business that we're in, but these are the type of facilities that we're operating that from an energy management perspective that we're focusing on are ready-mix plants, aggregate plants. We do have 2 asphalt plants. It's a very small part of our business, but we obviously, those are energy intensive and we focus some time on them. And for today's discussion, the 3 cement plants that are part of our portfolio. With the Energy Star program, we've been a member for just about 20 years now. And the program has an annual recognition process where they will recognize the programs that are achieving at the highest levels. And so this application process, we do it. It's an annual process, and we've been fortunate enough that for 17 years in a row, we've been awarded the Partner of the Year Sustained Excellence Program. It's the longest continual streak of any company in the Energy Star program, and for sure it's the longest of any industrial and cement manufacturer. And we're very proud of that. We display these recognitions everywhere we can and talk about our Energy Star award. So that's a company corporate-wide achievement. And the proof's right here in the data. Our energy intensity, by focusing on energy and energy management, we've had from left to right there, that's 2003 to 2020, our energy intensity, MMBTUs per ton, has had a dramatic decrease over the years. And it's a primary because we're focused on energy management, and using the Energy Star tools to achieve this. So let's get to the meat and the potatoes here. So the Rito Cement Plant is located in the state of Arizona. That red arrow there, this is in the southwestern desert of United States. We're just maybe 70 miles north of the U.S.-Mexican border. And the plant's been operating there since 1948. We're doing about 1 million tons a year, shipping into the local Tucson and Phoenix market right there in southern Arizona. Here's some historical pictures. Like I said, the plant was started building in 48. The first plant online in 1949. One kiln, one used kiln. 1953, a second kiln was installed. 1955, a third kiln now was installed. So we have 3 long dry kilns at that point. And then, there's a typo there. The fourth kiln with preheater, that was 1972, was when that plant was modernized with a preheater tower. So 4 kilns, and the largest one, preheater tower, in 1972. So as we know, these slides were kind of created for a broader audience. I think everybody online knows, what we're doing: mining limestone, crushing limestone, iron and aluminum, and having a high temperature process. I'm just going to push through this since our audience is very adept at this. The chemistry of a cement process, and obviously the preheater tower, where the cyclones are, a big part of the heat transfer process, and once again, clinker cooling, kiln, preheater tower, all these fuel intensive areas are a large focus for us. Now, on the engineering side of things, the technical side of things, that's we keep our focus on it, and how we maintain our focus is with our energy management practices. So as a corporate level, I'm the head of the energy team at a corporate level, but each cement plant has an energy team, right? They all have their duties, and in this case, the plant engineer is the energy manager for the facility, and he has, outside of their other regular duties, they also have this energy management focus where they have weekly meetings to discuss energy efficiency projects. What are they focused on? What are their targets? And we have a quarterly meeting where all 3 of the cement plants are broadcasting energy data at a quarterly level towards the executives at the corporate level, so that we can keep our eyes on all 3 plants, on their energy intensity and their processes. This keeps it at a very high level visibility to make sure that our energy efficiency is a top priority. So we're going to go through a few of the projects over the last few years that they've done. A major one we did a few years ago was we replaced our entire clinker cooler, put in a crossbar cooler, and the goal was it was, as I already said, 1972 was the original plant. So the cooler was in an aged condition and did need some maintenance. So we decided to do an entire replacement. We put a roller crusher at the exit to replace an impact crusher, and a tremendous increase in fuel efficiency by being able to recover more efficiently the heat in the cooler process. And this was a great success for us. We also part of that process is all the fans were damper controlled fans, and we replaced them with variable frequency drive fans. These are pretty much obvious necessities, but it takes these large projects to get these actions. Our quarry is a few miles away from the plant, so we have an overland conveyor. We just did a unique project where we had to do a typical belt replacement, but we chose a belt that was had some energy efficiency guarantees based on the materials of the rubber. We've been monitoring that. I'm just showing the energy data that we've been keeping track of to see whether or not, the benefits of that actual particular type of belt. We have the ability to consume alternative fuels, and there was a project where we bring that alternative fuels into in a tipping valve in there was had a lot of leakage, had a lot of outside air, cold air being introduced into the process, plus poor material flow. So we did a project there to replace that double tipping valve to allow a more efficient introduction of the alternative fuels, 1 to 2% efficiency improvement with that project. And, another great success. To tie in with the first presentation, fans are, as was said there, 20 to 30% of your electrical power in the plant. There's, as we all know, cement plants have fans everywhere. And we are pretty much in a constant mode of evaluating fans, testing data, testing, the air pressures, velocities, trying to analyze how our fans are performing. There's always wear. It's obviously a dirty air process. And we have done many, many studies. We even had a Department of Energy grant to do a full plant study a few years ago, and that had great benefits to help us identify which fans to focus on. And so we almost annually have some sort of a fan modification, fan housings, impellers, rotors, all sorts of fan modifications to keep maintaining our fan efficiency, because they will wear and that you will lose efficiency. So it's a definite focus for all of our cement plants and here at the Rita Cement Plant. A few years ago, once again, that 1972 preheater tower, so as you can imagine, things are getting aged. Well, the first stage cyclones, the preheater tower is the right-hand tower there, the left-hand tower with that hairpin loop, that's our vertical raw mill. So those first cyclones we're wearing, they were basically falling apart. The insulation around the cyclones falling out, and we had a lot of metal structure fatigue. So we could have just went with find the drawings, rebuild the cyclone, and put it back together. But we decided to do some, deep analysis, did some CFD modeling, and we redesigned those two cyclones. We redesigned it so that we could maximize our heat transfer, and we could the residence time in the cyclone could be improved, and the airflow, the differential pressure drop across the cyclone can be reduced, because then we also can have fan savings to reduce the amount of fan power required to draw across those cyclones. This was completed just about a year ago. It's been it was a great project, and we were seeing 3 to 4% efficiency improvements on the kiln. So all these are just continually adding and either maintaining efficiency or moving forward and getting even better on the kiln process. Compressed air is something that I think all of us know that is a utility in the plant. It's very actually energy inefficient, right? It's a horrible way to convert electrical energy to some sort of all other alternate energy, in this case pressurized air, but it's a tool that we use. So focusing to make sure we use it in the most efficient way, and also have compressors that are as efficient as possible is a big focus. We have regular monitoring of our system. We have our own ultrasonic leak detector where we do our own monthly surveys, but we also bring in experts to do full-blown surveys of the property. We had a Department of Energy did in 2012. And a different grant. We're always looking for people to help us out and find ways to improve our systems. So in 2012 we had a survey, and then just recently, in 2020, we have a vendor who was providing services, and the benefit of this was the vendor, who is a supply vendor, they'd offered this as a service without cost. And we just did that last year to do another survey. Something important to keep in mind is you can't just survey a compressed air system and walk away and think that you're done. It's almost annually, there are going to be changes, failures, operational changes, and you need to really keep going back and re-looking at your systems constantly. In the picture you're seeing there, that's a screw compressor. Right behind it, it's kind of hidden, but there's a reciprocating, an older vintage reciprocating compressor, which for its time and it's what it's done over the years, it's actually pretty good, very efficient compressor. But as they get aged, the maintenance and mechanical maintenance became very expensive to maintain its efficiency. So we've been replacing those with modern, efficient screw compressors. So, but like I said, keep your eye on your compressed air system and keep going back and looking at it. We have so our bag house, once again, older plants. So this kind of common theme here is older plants and try to keep improving and modernizing as you go. The dust that was collected in the bag house, the dust that's being obviously we're filtering out, it was being reintroduced back into the kiln at an intermittent basis. And so they would pump it into the kiln, and it was very bad for the process, and because it was up and down, right? Every few hours you introduce this kiln dust, and it would disrupt the process. So we recognize, obviously in the modern kilns, this is thought about, and what you do is you do right here, you put a feed bin in so that you can meter it in at a constant rate to minimize the transient, problems with introducing the dust. So we installed this dust bin, and saw about 1%, maybe as much as 2% improvement in fuel efficiency due to being able to keep a stable kiln, because we are metering in at a constant rate this dust versus the intermittent nature that we had been doing in the past. Microscopy of clinker, I think many of us know that this is out there and necessary. I just wanted to talk about it, that we do this, we monitor this, and always trying to analyze our clinker samples and make sure the process is operating, and making necessary changes by making sure you're watching obviously watch the chemistry, but watching the microscopy of the clinker is super important to us in the process. So here is the actual tool for a certification. Now, what does Energy Star certification mean? So if you take and you benchmark like type facilities, and there's certification processes for automotive factories, there's certification for petrochemical factories, steel mills, and in this case, cement plants. So all the cement plants in the United States, they are benchmarked against each other, and the energy and production data, which is provided by the Portland Cement Association, it's a blind look. There is no data as far as which plant is which, but they have this database of all the cement plants. And in this scorecard you got here, you put in your production of clinker, your production of cement, your energy consumption, which is electrical, your fuels, and any waste-derived fuels. So all that together, you're trying to create a profile of a facility and an energy intensity. And they calculate back to the source data, especially for your electrical consumption. What is your source electrical MMBTUs? And that combined, it creates a score. And the score is a 0 to 100. And 100 meaning you got the perfect plant. And of all the plants in the United States, 100 would be whatever that best plant is with that best energy intensity. And, the lower the number, the less energy efficient your plant is. If you're above a score of 75, you are now eligible to receive the certification from Energy Star. What's critical about, the Energy Star program is ran by the EPA, the environmental program here in the United States. And so as well as being able to score properly, you also have to be environmentally compliant. No violations, no environmental violations in the last year, no notices of violation. And so and when those two are combined, then you are eligible, and then you have an application process. There's a verification of data process. A professional engineer has to verify your data. And then once all that's done, then they can acknowledge you as being an Energy Star certified plant. Once we're certified, the next step always, in our opinion, and with Energy Star management practices, is getting people aware of this. People being internally, your employees, and also outside of the company. You want to share. You want to make sure that people know that, hey, that you've achieved something. It's super important for this process to keep things going. And in this case, this is a poster that goes around the plant, shows the employees what they swore was, what our greenhouse gas emission reduction was due to energy efficiency. And it's really important to get those employees aware. Here's a case of employee engagement, giving away things to employees. And this is a shirt that we made up and talking about our certification just to make sure and give it out to the employees. And it was really popular. And it's a good thing to share with your employees, making sure that they recognize that they're an important part of this process. Also, we do press releases. We want to make sure our neighbors know about this, to know that we're doing our best to be good neighbors and to be good environmental stewards. We had an industrial showcase. This is also an Energy Star program that only an Energy Star certified facility can kind of broadcast this as a showcase, and we bring in the public. Public came in. We had this sign-up sheet and toured them around the facility and showed them some of these projects that I was just displaying to you, the things that we're working on. This is very successful, showing the local community, what we're doing and how we're trying to become as efficient as possible. And so, the Energy Star process, the energy management practices, that they've helped this plant achieve the certification for 10 years in a row. We just got our 10th one just a few days ago, all the paperwork and process. It's by doing these improvements, we've been able to keep up with it. And every few years, the database is modified, right? There's always new plants being added, and there's older plants that are being decommissioned. And so the curve moves. And so some years, if you don't keep working at the plant, at energy efficiency, you could fall off of that score. And so we've been pretty proud that we've been able to keep moving forward and keep this plant certified. And I wanted to get through that as fast as possible, and I think I did. And that's what I have there, Thomas.
Thank you very much, Bill. That's a really inspiring. First of all, to see all the things that you've been working on right through the plant. I mean, the attention to detail is fantastic, and the way that you sustain that attention through the year, through all parts of the plant, all the way down to the clinical microscopy. It's very impressive, and I'm sure your stock has gone up even more this year with the energy prices rising. Has that impacted your plant, or are you feeling that energy price rise?
Oh, well, definitely. Yeah. Natural gas now we're primarily coal, but some natural gas is being used at that retail plant specifically. We are using a percentage of fuel, and definitely gas prices are nearly double what they were last year. Yeah. And it's pretty intense. Yeah.
Yeah, incredible, and just really highlights how valuable your role is. The process of going through the plant. Do you have a system, or are you really looking at everything all the time? And what are the areas that are really the most important to keep an eye on? If you had to highlight just one or two. I mean, you mentioned the fans as a particular area of interest, but are there any other areas that you would like to highlight?
Well, I mean, we all know that on a thermal energy basis, the kiln is the consumer, right? The fuel. You just said it, right? That fuel is that is the highest energy content. Now, the electrical energy is less of the MMBTUs, but it's the highest cost actually, right? The electrical costs are tremendous. So, we typically across our corporation, and this is something that, once again, Energy Star based, is you do a treasure hunt, and what you do is you kind of do a focused couple days of an event and you actually walk through the process. You get the employees involved, you get other people involved, and you try to, identify things, and that's kind of on an intermittent treasure hunt basis, but that energy process team, they're constantly looking at issues, and sometimes they come up as a maintenance issue. And if we're going to be replacing a fan, well, let's replace it with the most energy efficient, item, right? So it's kind of a multi-pronged approach, I guess. Looking at both, a lot of fan work, the fuel processing, and in California, our cement plants there, to talk about carbon and carbon pricing in California, we already experienced that, right? We are in a cap and trade program, so there's an additional thought process there for fuel because of the fact that carbon has a cost, and then we have to work with that in California.
Yeah, sure. Similar to what's happening in Europe, of course, with the European trading system. And I guess Energy Star, it's the EPA that organizes that. Do you know of any other systems elsewhere in the world that work on that basis? It seems to be a very successful program. And how many plants in the US do you know are succeed in making that top cut over 75%?
So as far as other parts of the world, now we do have, Energy Star has a relationship with the Canadian environmental program, and they basically share this Energy Star program with Canada. As far as outside of the US, I'm not sure of an Energy Star style program. As far as the question on how many, I could find that. I mean, if you go to the Energy Star website, there's an industrial location and it'll tell you exactly how many plants are certified. Now, interestingly enough, in Arizona, there are 3 cement plants in Arizona. They're different companies, and all 3 are certified. I'm guessing somewhere in the range of 25 plants in the U.S. are certified, but right now that's just a guess. I have to go verify to see who's on the list again.
Yeah. And just sort of more generally about energy, do you have any kind of other plans? You did the cyclone modification, that was very successful. They're quite big jobs. Do you have any other big targets that you're kind of looking at maybe in the next 2, 3, 4 years? Is there anything that you think you'll be carrying out in the plant?
For this plant specifically, we've got to focus on potential stacker reclaimer work, like completely replacing the stacker reclaimer system. Trying to think what else we might have going on. At the other cement plants, we're installing a new vertical raw mill at our Mojave plant. That should have really big impact on the process and on keeping the reliability up at the plant. So that we're really excited about that process. Trying to think for the retail plant specifically. I mean, they've done a lot of work in the last few years. So. And the other cement plants are quite jealous of all the attention they've got, which, it's almost in a competitive capital budget nature. And I don't know if anything else is going on at the cement plant, besides those, and your normal maintenance and, maintaining a plant, which is very critical for energy management. The maintenance team is vital that they're maintaining a reliable plant because reliability is key.
And in terms of renewables, have you looked at that at all? Wind power and solar. I mean, down in Arizona, there's got to be a lot of potential for that. Is that something you're actively exploring?
Yeah. So our Mojave cement plant has 24 megawatts of wind. We're behind the meter on the property. About 20% of our electricity is wind generated at the Mojave cement plant. I am constantly in discussions with renewable entities, and at the Rito cement plant, we are in the process right now of a fairly large system. It's trying to find the best fit. Sometimes it's land issues. Where can you site it? Getting it. Because siting the solar system right on top of a cement plant, that's not a good idea, right? A lot of dirty conditions, and so we have some property there. So we're right now in the middle of it, and I'm hoping that we keep moving forward. There's just always hurdles to overcome, but we have definitely a potential large solar project at Rito coming down the road if we can make it work.
Brilliant. Well, that's excellent. Thank you so much for your time and for sharing that excellent presentation. I'm sure it's made a lot of other people look on and think what they can do in their own plants. It's really impressive, and we look forward to hearing more about it in future. So to Bill, thank you very much for your contribution, and to all our speakers who've given their time and presented today, Wrights from India and Claudius Peters from Germany. To all of you, thank you very much. That's all we have time for today on our November technical webinar. Again, we're going to be returning in November, at the end of the month, with cemtech Americas. We'll be hearing from all sorts of interesting people, the PCA, Portland Cement Association, and their framework for decarbonisation. We'll be hearing from Canacem, the association in Mexico. We have speakers from Cementos Argos in Colombia. We'll be looking at various other technical areas with a little focus on what's happening in North and South America. So if you're interested, please do check our website or look out for your email and sign up for that event. Just a quick mention of the Global Cement Report, published just a month or so ago. We update this every 2 years. It's a huge project. We cover around 170 countries, looking at the markets, supply and demand, trade, capacities, new projects. There's a big database of statistics and our online plant directory, which geolocates pretty much every plant in the world. It's a great resource, especially if you need to monitor the markets and know what's going on around the world. So do take a look at the Global Cement Report, 14th edition, more information on CemNet. But that's all for us today. Thanks for joining us. Please get in touch if you'd like to participate in any of our future webinars, or if you'd like to contribute to the magazine, International Cement Review. We'd love to hear from you. Just look out for my email, Thomas Armstrong, and reply to that, and I'll be in touch. So thank you very much, and we'll see you all hopefully for cemtech Americas later on this month. Goodbye.